Okay, so the first problem, or the first question in problem number 5 is we're trying to find, first of all, absolute minimum and maximum values on these functions. And for this one, we have an ln function of x squared plus x plus 1. And the interval that we're looking on is from -1 to 1. So remember that to find your absolute min or max values, you need to consider both the endpoints of the interval that you're looking at, as well as any critical numbers that fall within that range. So our idea here is we need to find the critical numbers of this function that are between -1 and 1. And from there, we can just test values and see which one has the biggest y value, that would be the max, which one has the biggest, or the lowest y value, that would be the min. So first, let's do the derivative. So remember, when you're doing the derivative of any ln function, you're going to put the thing that you're taking the derivative of on the bottom, or sorry, the thing that you're taking the ln of on the bottom, and you multiply by the derivative of that on the top because of the chain rule. So the derivative of ln of anything you can think of is 1 over that, but you always multiply by the derivative of the inside, so you can just put that on the numerator, and that would be 2x plus 1. So if that's your derivative, we need to find the critical numbers that are in between -1 and 1. So we need to find the critical numbers of f prime of x. Remember that, or critical numbers of f of x, which means that for the derivative, we want the numerator or denominator to be 0. This is another example, just like the problem, or the question in problem 4, where we don't really need to check the denominator, because if this denominator was equal to 0, that would have meant that what was inside the ln is 0, but you can't do ln of 0, that wouldn't be in the domain. So even if this could equal 0, the x value that would give you that is not in your domain, so we don't care. We just set the numerator equal to 0. 2x plus 1, which means x is -1/2. All right, x equals -1/2 is in between -1 and 1, so we want to check that. So now we just check all of our points. So what we're going to do is we're going to do f of -1, we're going to do f of -1/2, and we're going to do f of 1. We're going to see what all of these give us, and we're just going to pick the biggest one as the max and the smallest one as the min. So if we plug in -1, we get -1 squared, which is 1, minus 1, which is 0, plus 1, which is 1, and we're doing the ln of 1. Well, the ln of 1 is 0. So f of -1 gives us 0. Let's try -1/2. So -1/2 squared would be 1/4. 1/4 minus 1/2 would be -1/4. And then if you add 1, you get 3/4. So we get ln of 3/4. And f of 1, we would just add 1 and 1 and 1, which is ln of 3. So we're tasked with which of these is the biggest and which is the smallest. So to answer this question, you just need to know some things about your ln function. ln 3 is just some positive number. But ln 3/4 is a negative number, because if you remember, your logarithm ln of x graph looks like this. So this is y equals ln x. And this point right here where it crosses is 1, 0. So ln of 3 is some number over here. ln of 3/4 is actually negative because it's the x value is less than 1. So this is 0. This is a negative number, and this is a positive number. So therefore, our min is the negative number, and our max is the positive number at ln of 3. So that's our absolute max, ln of 3. Our absolute min is ln of 3/4.
The Teaching Center, UF's Learning Resource Center.